Hey guys, Ben with Big Stuff here. So today's video, we're going to be talking about the internal Gen 4 ECU boost controller. We call it the GN boost controller. It's basically for a street-based application, or you can use it for a drag race application as well. This does not involve any type of CO2 control. If you want to use any type of CO2 control, we have a CO2 boost controller option as well. It's 150 bucks on top of the base ECU price. That unlocks the internal CO2 boost control. You'll need a hardware pack, which has a wiring harness, solenoid valves, pressure transducer, and stuff like that. But for a lot of guys, they can actually get away with running just our GN boost controller application itself. So the first thing here to remember is that on our website, BigStuffTPM.com, we have a whole Gen 4 tech support section. We do have the old school Gen 3 tech support section as well if you still run on a Gen 3. The Gen 4 is almost a direct replacement for a Gen 3, so if you're looking to upgrade, please reach out to us. The Gen 4 basically slips right in place of the Gen 3. We give you a new O2 sensor, and depending on the type of options you want with it, there may be some new harnesses to add on, but it's almost a like-for-like swap. So if you had a Gen 3 ECU where you have external boost controller, bump box, all different type of external add-ons, you could put a Gen 4 in its place, have everything all internal inside one ECU. So reach out to us if you have any questions about that. So in this Gen 4 tech support section, you're going to see down here we have the GN integrated boost controller document, and I've got it loaded up right here. And how this works is that it's very simple. We simply have a MAC valve, which we saw on our website. It interfaces with pin B on the boost connector, okay? Pin B basically is going to pulse width modulate a ground signal to control this MAC valve. So the MAC valve gets 12 volts on one side for wiring. The other side goes to the ground, which is a pin B, which is a ground signal. And that's it. That is the wiring for the boost controller itself, okay? Now, mechanically, how you plumb the guy is, number one is going to be the exhaust port. Number three is going to be the air supply from the engine. So we recommend just coming off the turbo itself. You can run to the engine itself, but then that line will always have vacuum on it, which can introduce a vacuum leak. But it will work. But we recommend just coming off the turbocharger or just somewhere where you're just going to see boost pressure itself, not necessarily engine vacuum. Number two is going to go to the outlet port of the wastegate to the bottom port of the gate. Very important, to the bottom port, okay? The way that this boost control works, it's very simple. We actually use the wastegate spring to modulate to maintain your boost controller target. So let's go over boost control 101 if we do not have a MAC valve, if you simply had a boost reference line coming off the turbo going to the bottom of the gate, okay? Typical way of a boost controller or typical way of boost control with any wastegate is if we have about an 8-pound spring inside the wastegate, as soon as we start making about 8 pounds or so of boost, that spring is going to start to lift and the wastegate will start venting the exhaust gases, so you should maintain around 8 pounds of boost or so. Obviously, that can vary greatly depending on wastegate size, back pressure, etc. But in a normal application in the real world, that gate should start to crack and maintain around 8 pounds of boost. So all we're doing in this application is taking that manifold pressure and we're going to restrict it. So we're going to make that 8-pound spring. Let's say you want to make 15 pounds of boost. Well, we're going to take that 8 pounds of pressure and we're going to bring it back. We're going to scale it back. We're going to maybe only pass 2 or 3 pounds of boost to it so that the spring mechanically is actually shutting down that exhaust flow to keep going through the turbine housing. And then when we get to 15 pounds of boost, we then start cracking the wastegate to then maintain 15 pounds. This works great. We have this being used on a lot of applications. It's very simple. You just simply are modulating the bottom port of the gate to maintain that boost pressure. Now, if you're trying to maintain some crazy high boost pressure, 30, 40, 50 pounds, you may get into an issue where mechanically the spring just isn't enough, and you may have to go to a CO2 setup so you can actually push down on top of the gate with CO2 pressure to maintain it. But if you're trying to maintain 10 to 20 pounds of boost, this controller will work great. It's very simple. It's literally a 2-wire hookup from a switch 12 volts to pin B of the boost connector, and you're done. Okay. So again, on our Gen 4 tech support section, we'll leave a link to this down below in the video itself as far as this PDF document, also where to go to for our tech support section. But that covers the installation of the MAC valve and the wiring. So let's go into the software and talk about how to actually set this guy up, okay? So we're using the new interface software right now. You may not have it, but it's okay. You're simply going to go into your software where it says Boost GN, your calibration, okay? In this Boost GN, you're going to have a couple different menus, but we want to go to the Boost parameters, okay? Inside the Boost parameters, here's how we're going to configure this guy. So you have to enable the Boost controller, which is right here. That says closed loop Boost control. You want to enable this. You're going to have a choice of a data source for the Boost controller duty cycle table. We're going to go over this in a little bit, okay? But you can choose different axes if you want to maintain the duty cycle that comes out of the solenoid. Again, we're going to go over that in a little bit. We actually started looking at some data logs. You're going to have a closed loop TPS on threshold and off threshold, okay? So in this case, once we get above 50%, the boost controller is going to be allowed to work. When we're below 40% TPS, we're not going to have any signal going out. This is so we're just not constantly pulsing a ground to that MAC valve to try to maintain a boost control. When if you don't need it, then we'll just only enable it above 50%, okay? We're going to have some boost control positive limits. Again, this is going to be based on the duty cycle table. We can go above 25% of the values or below 25% of the values. This next one here is very important. This is a closed loop boost delay time. What we found is in the very beginning of setting up this boost controller, sometimes it can overshoot and undershoot if the boost controller triggers too early. So basically we say, you know what, once the TPS parameters met, we're going to wait 1 second before we actually start to boost control. Okay, and what that does is that lets the system mechanically settle out. And then at that point, after 1 second, the PID takes over and it'll start controlling the MAC valve to maintain your boost control. Again, it works great, okay? You're going to have 4 different axes you can choose as far as how to control the wastegate pressure. It can be done based off of time, off the SR2 timer. If you're running the SR2 option for the power management, you're going to have to be based off mile an hour, which is the most common for a sheet application, engine RPM or gear, okay? You can also have the old boost kick, which is just simply your scramble button. So if you press the scramble button, it will add 5 more pounds to your target, whatever is in your target table. And then this right here is this the proportional gain. This is the PID control itself. You can typically run 100 or so, and that should be fine for how fast the boost control operates to get control of the signal itself, okay? So this is your base parameter settings. Again, this is where you'll just come in here. The base typical factory default settings typically are pretty good, but you can change the y-axis of the boost controller duty cycle table. You can adjust the TPS on-off thresholds, but this stuff down below as far as closed loop control limits, delay time, all that stuff should be pretty much configured for you, okay? So the next table you're going to want to look at here is, since we've chosen mile an hour, we're going to have a desired wastegate mile an hour curves. So if we're on curve number 1, in this case, we're going to choose 8 pounds of boost, okay? This is manifold pressure. This is not CO2 pressure. This is boost. Number 2 would be for 3 pounds of boost. Number 3 would be for 6 pounds of boost, and so on, okay? So our curve is from 0 to 120 miles an hour, okay? Again, this is just for example. You can configure this any way you want, but right now, basically, we're going to be targeting about 8 pounds of boost, okay? The next table you're going to work with here is this duty cycle table. Now, what we've done is this is the throttle position itself, okay, going on the y-axis, and the x-axis is desired boost, okay? So what happens is when the TPS threshold is met, that table is energized, okay? But it's only going to be energized after 1 second. So as soon as we hit 1 second, wherever you are in this table, it's going to start applying that duty cycle output to the solenoid valve to start maintaining your manifold pressure. You're going to see that in the log. Okay, so we recommend something like this here, a very low duty cycle percentage on the lower sections. And then as you start to increase the need for more boost, you're going to have more duty cycle. And you have to remember, you start needing more duty cycle when we're actually restricting the signal going to the bottom of the gate, because we need that spring to actually close to make more manifold pressure, okay? That's how this table works, all right? So these are the 3 tables that you're going to be concerned with: the boost parameters, the wastegate mile an hour curve, the boost duty cycle table. These are your 3 base ones. You can also set up a boost cut safety if you'd like here, so that boost cut safety in this case would be 10 pounds. The boost cut hysteresis is 1, which means once we get below 9, it'll actually turn the safety off. The boost cut delay time means that we're going to wait 2 seconds before we actually trigger the safety cut, and we're going to set an ETM value of 20 so that when we actually meet these thresholds, we're going to activate the rev limiter. It's going to go out at a 20. Very important to remember, the rev limiter only functions on coil unplug applications. This will not function if you have any type of distributor-based or any type of ignition system other than a coil unplug system. Okay, very important to understand that. You can also set up some minimum engine RPMs, minimum throttle position, minimum boost, and a minimum SR2 timer if you'd like to also add some more configuration to the boost cut safety itself. Okay. We also have some boost modifiers here. We're going to have another video on this, but basically you can have an over rev feature so that on the starting line, if it doesn't make how much boost you want, you can add some RPM for it to overshoot and then come back down when the boost target is achieved. And you can also add some 1D or some 1D boost curves to actually allow for either more or less boost based on some X and Y axes, some custom tables. We're going to talk about that in a different video as well. So let's look at some logs here. So right here, I've got 3 logs lined up here back to back to back, okay? And what you're going to see here is in this log itself, we're looking at RPM of the engine. We're looking at the duty cycle boost increase, okay? Because we're only going to increase the output percentage of the solenoid to start to maintain, okay? We're going to modulate this duty cycle boost increase to maintain. We're not going to have a decrease being used. Duty cycle boost increase. I'm using throttle position to see that I'm at 100%. The boost closed loop duty cycle percentage, this is very important. We're going to talk about that in a minute. We've also got this boost incorporated PID term. You're going to see that this matches the duty cycle because this is the PID loop running to maintain this duty cycle based on the required boost, okay? So let's zoom in on this a little bit here. So what you're going to see here is in purple, okay, this purple line right here, this is our boost. So our target boost in this case is 8 pounds, okay? 8 pounds is where basically we're targeting this number all the time, 8 pounds, all right? So at 8 pounds of boost is what we're going to target. Now, what I want to show you here is right here, okay, where you actually start to see some duty cycle taking place right there. I go to 38% on the duty cycle, okay? So what I'm going to do is as soon as that goes true, I'm going to zero my table out down here, okay? I'm going to zero this out. And you can remember that we had a 1 second delay, okay, based on the boost controller enabling. So you can see that right here at 1 second, okay, now the closed loop boost control is actually taking over. But when the boost controller enabled, it went to our default spot in the table. So as soon as the boost controller enabled above our throttle position, okay, it went and sat at 55% because right up here in our table, you'll see here, we're sitting right in here. Okay, so I was at 100% TPS. Now it kicks on my base table, which is right here. I'm only at 4 pounds of boost. Okay, so now right there at 1 second, you'll see here that the boost controller now takes off and starts running. The boost controller duty cycle, the close of duty cycle is at 0 after 1 second right there. Now it starts to ramp up. So what it's doing here is because we were a little under the target boost, it was adding 7.5% to my base table. So you'll see that in my base table right in here, I'm around 55% or so. It's adding 7.5% of the closed loop duty cycle to get to my target boost, which is 8 pounds. So you'll see here it gets to 8 pounds. Now we're hit about 8.5 or so. Now the PID is coming back down and we're maintaining 8.5, 8.4, 8.3, 7.9. There's 8, 7.6. Now it started to ramp back up right there. But that's how the boost control works. It simply just grabs it after the time delay and it'll start controlling the bottom of that solenoid valve to maintain around 8 pounds or so, okay? And you can see here that the PID was coming back up to maintain that 8 pound number, all right? So that's one part of the log. Let's go look at a different part of the log right now. Let's go zoom out here and let's look at a different one, okay? So now we'll see, here's another one right here, okay? So now I'm gonna zero this out. So let's go right there. I hit 53% of the duty cycle. I'm going to zero this out. So now you'll see here that I'm sitting at the table at 55%. My desired target is still 8 pounds of boost, okay? Right there, I hit 1 second. You can see down here. And then now my boost controller is allowed to work. Here comes my duty cycle. I'm now adding 10%, 11%, 12% duty cycle. I'm right at 8 pounds. I'm at about 90% throttle. And you can see here that the boost controller is leveling off, 8.5 pounds or so, 8.5 pounds, 8 pounds of boost, and right there. And you can see here that it was maintaining a little bit above 5%. So we were only adding 5% based on our PID loop to maintain our target boost of 8 pounds. So the base table is very close. That's what that means, okay? If I was adding on the close of duty cycle 50%, right, that would mean that this table was way off. Because I'm sorry, 25%, that was the max to be allowed to add. That would mean the table's way off because it had to add a ton of duty cycle to get to my target set point right there. Okay, so 5.5 more percent over the base table, that's great. That's going to give you some great control over boost. Okay, and then again, once the throttle let go, it shuts off right there. Now I'm at 8%. Everything turns off, all the duty cycles, the PID loop, everything turns off, and now you're just simply back to your base ECU running with no boost control. Okay, here's one more we can look at here. So again, let's go out and let's zero where the boost control turns on. So right there, so we'll zero this out. Okay, right there, the boost controller just turned on. And then there's my 1 second delay again. Okay, and then here's right here. Here's the duty cycle of the boost controller taken off. Okay, now we're only adding, this may look like a lot, but this is just 10%. So we're adding 10% over our base table. Remember, our base table has around 55 to 56%. Okay, so now we're trying to target that 8% again. Okay, so now when I come over here, here's my boost, trying to target 8 pounds, 8.5 pounds, 8.3 pounds, 8.2 pounds, 8 pounds, 7.8, 7.9. We're trying to maintain 8. And as you can see here, the PID went up. It came back down because we were a little bit over. Then it starts coming back up, and it's going to keep you right around that 8-pound mark. You can see here, start to flatline around the 8 pounds. When you have a mechanical boost controller like this, sometimes you're going to have a little bit of oscillation because mechanically stuff has to catch up, right? That's why this PID starts off and takes off, because you can see down here our target is 8 pounds. Well, we weren't at 8 pounds yet. Then as soon as we got to 8 pounds, it started to come back down. That's how you can adjust that proportional gain number so that if it either is reacting too slow or too fast, you can get this curve to work right so it can actually grab the boost controller correctly. Okay. So again, in the log, this is what you're going to want to look at for the GN boost controller. You're going to want to look at the duty cycle boost increase. Obviously, you want to look at your throttle. You're going to look at the boost close-up duty cycle percentage. You're going to look at the PID term. Now, the PID term and the duty cycle is going to be the same thing because that's what the proportional output is of the boost controller. So it's going to match what the duty cycle is. But you'll see again that that duty cycle close loop, that this percentage right here, this 9.5%, for example, that's what's added to our base table. And again, purple is boost, and then the mile an hour is in the green. So you can see here about 122 miles an hour, 125 mile an hour, finally levels off. We're maintaining our boost around there. Okay. So again, that's how the GN boost controller works. It's very simple. It's extremely accurate. You can dial it in to be very close, but again, you have to remember that we do not go to the top of the wastegate with this controller. We just simply use the bottom of it to maintain, okay? And that will then modulate the pressure going to the bottom of the gate so that it can actually maintain the target boost that you want. And you have to remember, again, if you're trying to target some very high boost pressure, you may want to get some stiffer springs so that mechanically those springs can push down to maintain the higher boost that you are calling for. But it will work. It'll just take some more trimming on your end mechanically with more springs to get it to go. Obviously, if you're a drag racer, you definitely want to use the boost controller, the CO2-based boost controller, because then you can have CO2 on top of the gate, ultimate control. Very common way to do it. That's the best way to do it if you're drag racing. But for the street-based world, this is a great boost controller to use. So again, if you guys have any questions, please feel free to go to our website at bigstufftpm.com. You can send us an email at support@bigstufftpm.com. Please check out our socials on Facebook and Instagram. Thank you for checking out the video, and we'll see you on the next one. Thank you.